Hi, welcome back. In this video, we're going to talk about inequalities in two triangles. Now, if you are struggling with this topic, I strongly recommend you to first watch a previous video, Inequalities in One Triangle. Because if you understand the concept or the idea behind what happens inside one triangle, then what happens in two wouldn't be much of a difference. It just carries on and it's actually much simpler. So, if you're struggling with this concept, go back and watch Inequalities in One Triangle, right before two triangles. All right, let's get right to it. So the Hinge Theorem says this. We're going to compare two angles. Let's say that I have angle A measures 50 degrees, and angle D, let's say that this angle measures, let's say, 40 degrees. The Hinge Theorem allows you to compare the opposite segments. You can actually compare segment BC to segment EF. Since we're dealing with angles being opposite to the sides, I know that angle 50 is across from BC, and angle 50 is bigger than angle 40, which is across from EF. So if 50 is bigger than 40, I can conclude that segment BC must be greater than segment EF, right? If the angle opposite is greater, then this angle should be smaller. If this angle is greater than this angle, then this side should be greater than this side. That's basically the Hinge Theorem, and you can actually do it backwards as well. If you're given the side length, let's say that the side length is, I'll put this in blue, 20 centimeters, and this side is 10 centimeters. If you're given the side lengths, you can also predict that this angle, angle A, should be greater than the one opposite from the 10 centimeters, because 20 is bigger than 10. So the Hinge Theorem really just compares two triangles, while in the previous video, we're comparing each angle to themselves or to each other within one triangle. We're now extrapolating and we're pulling to two separate triangles, and this is going to be possible if they share sides in common. So if these sides are congruent, if the two sides are congruent and the only thing that you're interested in comparing is the angle, how does that angle affect the opposite side? All right, let's do a few examples and then we can call it a day. So here's an example. We want to compare angle STR to TRU. STR, I'm going to use the color blue. Starts here, STR. We're going to compare this angle to TRU, which starts here, TRU, this angle. So I'm going to look across from the angles. Angle T is opposite to 31, and this angle R is opposite to 30. So, since 31 is greater than 30, I can predict that this angle should be bigger than angle R. STR is greater than TRU. That's really it. Here, I'm going to do the converse. Now I know the angles. I want to predict the sides. How does PQ compare to RQ? So I look at the angles opposite to them. Angle S on the left side is opposite to PQ, and angle S on the right side is opposite to QR. Since 95 degrees is greater than 85 degrees, I know that PQ must be longer than QR. And that's really it, guys. If you know the angle measurement, you can compare the sides, and if you know the sides, you can compare the angle measurement. This Hinge Theorem is very powerful in the fact that you can combine and compare two separate triangles that have things already in common, right? Notice how they share this side, so this side is congruent, and they're both 7, so this side is congruent. The only difference is the angle between these two sides, so we can compare the third side to each other. All right, if you found this video useful, go ahead and hit the like button, And if you have not subscribed to it already, what are we waiting for? All right, everyone. We'll calculate later.